Hello everyone and welcome to my channel Octopus Math by Sahiba. Now for question 8 we've been given that there are two circles with center O. That means these two circles are concentric, and then ABCD are points on the circumference of the larger circle and EFG are points on the circumference of the smaller circle, and CGD. Okay, let me locate CGD. These are the points in a straight line, and it's also the tangent of the smaller circle, and CFB is also a tangent. This is given right here. And the lines A, E, O, C and the line FG intersect at X at 90 degrees. So this X, all the four angles are 90. I'm just going to write it down. This is 90, this is 90, alternate, everything is 90, 90, 90. Right. So yeah, all four angles are 90. I'm not mentioning all of it. All right. All right. It says part A, find each of these angles as simply as possible in terms of Y. Okay. GEO. Okay, so GEO. This is G, this is E, and this is O. So I'm going to label it A. Also give reasons. Okay. So let's see. Right. So if we look at this triangle, let me just change the color. I'm talking about this triangle, right? So what we know about this is that OE and OG are equal because OE and OG are the two radii on the circle, right? So these two angles are going to be equal. So if this angle is, let's say, A, this angle has to be A because of an isosceles triangle's property, right? And this angle has to be 180 minus A. Sorry, 180 minus Y, right? Because this is whole 180 degrees, right? So we know that A plus 180 minus Y should be equal to 180 because the sum and 180 are cancelled. 0 is equal to 2A minus Y. Turns out that because we were interested in angle A, GEO, right? Just GEO is angle A. So it's 2A equals Y and A is half of Y. So in terms of Y, if we need to give our answers in terms of Y, that means our answers must have Y in it. So it's going to be half of Y because, and our reason could be that this is an isosceles triangle. Maybe you could write that EOG, because EOG is an isosceles triangle. This is one reason you could write. Okay, moving on. GCX. So let me, this is G, this is C, and this is X. So let me just write it down. Okay, so using this triangle, I don't think it's gonna be a suitable choice. I think choosing triangle OGC is a better choice because this is pretty obvious. That this angle OGC is 90, and the reason for this being 90 is that the line CGD is a tangent to the smaller circle. So OG is the radius on the line, on the tangent line CGD, right? So it has to be 90 degrees. So I'm going to take up this triangle, right? Let me just redraw this triangle so it's easier for you to understand. This is O, this is G, and this is C. This is angle B we need to find out. I just named it B. This is Y and this is 90. So if you want to calculate the angle B in terms of Y, it's going to be 90 plus Y plus B equals 180. And Y plus B equals 90. And B equals 90 minus Y. Okay, so this is because, okay, the reason you could say that because OG is tangent to CGD, because OG is tangent to CGD, and OGC is 90 degrees. This is how I like to explain. As long as your reason is correct, they have no intentions to deduct your marks. So part 3 is angle DAB. I'm just erasing everything. So we need to calculate DAB. I'm just going to, this is DAB, so this whole angle is going to be C, and because AC is the diameter, angle D and angle B have to be 90 because B and D are on the circumference, right? And because CGD and CFB are the two tangents on the circle, it defines that CG and CF are going to be equal. This angle was, if we recall from part 2, GCX was 90 minus Y. So because this is an isosceles triangle, so this also has to be 90 minus Y. So 90 minus Y times 2, because these are two angles. So it's going to be 180 minus 2Y, right? And because A, B, C, D, cyclic quadrilateral, so therefore angle A and angle C have to add up to 180 degrees, right? So angle A is actually small c that I've named it, the whole angle, and for C it's whole 180 minus 2y equals 180. So this got cancelled and C is equal to 2y in terms of y. Okay, the reason is because ABCD is a cyclic quadrilateral, and the other reason, I mean a supportive reason, you could say that GCX is equal to FXC. So GCX is equal to FXC, right? So I think this should be okay. Complete the sentence. Triangle EGC is congruent to triangle. Okay. So E, where's E? E GC. This should be EFC, right? Because everything is equal. So it's going to be EFC, right? Okay, prove that ADC is similar to OGC. ADC is similar to OGC. We need to prove this. Let me erase everything else. Because we are not given any sides, so in order to prove similarity, the only option is double A. If we prove this somehow, we will be able to prove their similarity. Right, so this is 90. We know it already because AOC is the diameter. And this angle D is the angle of a semicircle, so D will be 90 degrees, right? And because OG is tangent to CGD, this angle has to be 90, right? So angle D and angle G both are 90. So D corresponds to G, right? So we just proved it. One angle is done. Okay, now for the second angle, how about we take OCG? I'm writing it here because it's, easier for me to see the diagram and write it together. So, okay, OGC and ACD. These two angles will be equal because it's actually itself, right? It's OGC, the angle is same as ACD. So it's the same angle. The reason is itself. Second angle is done, so it's proved. And let me show you how to form the answers. Give a reason for each statement you made. So because we have 2 marks, 2 statements are good. One statement was OCG and ACD. Because it's itself, I mean the angle, it's the same angle. So just a keyword is fine. They don't need whole grammatical sentence. And then ADC and OGC. ADC is equal to OGC is equal to 90 degrees. So yeah, 2 angles have been proven, and we can also write that this is the case of similarity is double A. Okay, what special type of quadrilateral AOGD? So let me erase everything again. So AOGD looks like a trapezium to me because if we've proven that these 2 smaller triangles are similar, that means it eventually tells us that OG is parallel to AD, and this looks like a trapezium to me because in a trapezium we always have a single pair of parallel sides. So OG is parallel to AD. Looks this is definitely a trapezium. Right. Find the ratio of OGC, the area of the triangle OGC, area of the triangle ADC, OGC, ADC. Okay, let me quickly write it down. OGC, ADC. Okay, we need to do this. Right. So OGC and ADC. Okay. So we know nothing about the sides, but we can still figure it out because this is this OC and AO is the radius, right? Okay, AO is also radius, OC also is the radius, so it means that these two lines are equal. So I'm just assuming if this length is x, this also has to be x, and together the whole length from A to C has to be 2x, right? So because we are interested in the ratio for the areas, right? So let me label for the area of OGC to be A1 over the area of ADC to be A2. This gives the corresponding length on the sides of these triangles whole squared. I mean the ratio whole squared. So L1 is any length on this triangle OGC. So because we know nothing about the other two sides, let me take L1 to be on the triangle OGCs. So this is OGC. So we're talking about this only length we know. So this is assumed to be X, right? So I'm just calling it X and divided by L2. L2 should be corresponding. We cannot take any other length, but because we have taken this length, so we have to take the corresponding length of the whole triangle, because L2 is basically the corresponding length on the triangle ADC. Turns out to be 2x. And because of the formula, we have to take whole squared. X and x are cancelled out. A1, A2. The ratio of A1 to A2 is going to be 1 squared is 1. And because we're writing out in terms of ratio, so 2 squared is 4. 1 ratio 4 should be the answer. Okay. OGC to ABCD. This is again area. Let me quickly erase everything. So OGC is this, right? And ABCD. So A, B, C, D. Okay, the whole thing. All right. Okay, so if we see that ADC is congruent to ABC, we just proved it because of two angles being equal. Like if this angle is equal to itself and this is 90, this is also 90. If two angles are same, okay, and the two lengths are also same, because if this is equal to this angle, then means this line and all the lines are equal because it's in a circle. So it does guarantee you that these two lines are equal, and turns out to be that ADC is a congruent triangle to ABC, right? It's just a mirror image where AOC is the line of symmetry of the triangle ABCD, right? So what we can understand from this point is that if this is congruent, then the area of the triangle ACD must be equal to the area of the triangle ACB, right? So what we know about the previous, from the previous one, is that the ratio of OGC, the area of OGC, the triangle OGC, and the area of triangle ADC is 1/4, right? So if I call this whole thing 4 parts, it's not 4 centimeters square or 4 inches square, it's just 4 parts, right? So, and this whole thing to be just 1, if this ADC is whole 4, then this also has to be 4, ABC also has to be 4, right? So the angle ABCD has to be 4 plus 4, 8 parts, and OGC is again 1, so it has to be 1/8. Subscribe to my channel Octopus Math by Sahiba for more videos.